Hi everyone, today we're going to learn about the primary trigonometric ratios. We call these trig ratios for short. There are three of them, and they exist whenever there are sides and angles being compared in a right-angled triangle. To use the trig ratios, we need a reference angle, and so the angle BAC is marked in this triangle. We'll use this as our reference angle, and we'll put a symbol to represent the unknown value of this angle. Usually the symbol that we use to represent an unknown angle is called theta. It's a Greek letter, just like pi is a Greek letter. So theta is a circle with a line through it, and we place it at the angle that we're going to use as our reference. Once we know what we're going to use as our reference angle, we can label the sides of the triangle. So the side that is across from the theta, or the reference angle, is known as the opposite side. We already know the hypotenuse is the side that is across from the right angle. And this leaves the third side, which we name as the adjacent. The adjacent side length is the one that is between our reference angle and our right angle. So our three primary trig ratios are called sine, cosine, and tangent. You can see how they're shortened to sin, cos, and tan. Each of those ratios can describe a proportion within the triangle. So the sine of our theta is going to be equal to the opposite value, or the opposite length, divided by the hypotenuse length. The cosine of theta is going to be equal to the adjacent length over the hypotenuse length. And the tangent, or the tan of theta, is going to be equal to the opposite length over the adjacent length. These will always be the ratios that you will use. These are the formulas for the primary trig ratios. There's a little trick we can use to remember these formulas. It's called SOHCAHTOA. And what it does is it spells out for you the values that you need to place in the different positions of your ratios. So sine is the S in SO. The OH is the opposite over the hypotenuse. Ca represents the cosine of theta being equal to the adjacent over the hypotenuse. And the TOA stands for the tangent of theta is equal to the opposite over the adjacent. So what you need to remember is SOHCAHTOA as a phrase, which will help you as a device to remember the formulas. You'll notice in these diagrams that sometimes when we type out the theta using a computer, that rather than using a theta as a symbol, we might use a star as the reference angle. So in the first example, we have the reference angle up at the C angle. This means that the opposite is going to be across from that, or where the 13 meters is. Our hypotenuse, of course, will be across from the right angle, so that will be the 14.76. And the adjacent will be between the reference angle and the right angle at 7. Now we can use this information and our trig ratios to set up our proportions. So the sine of theta has to be equal to the opposite over hypotenuse. The opposite will be the 13, and the hypotenuse will be the 14.76. We can sub this into our fraction. And then you can see that there's another equal sign asking us to evaluate this. To do this, we'll just divide the top number by the bottom number. For our cosine, we'll know that we have the cosine of the reference angle is equal to the adjacent value, or 7, over the hypotenuse value, or 14.76. Again, to simplify or evaluate this, we'll divide the top number by the bottom number. Our tan ratio will be tan of the reference angle is equal to the opposite value of 13 divided by the adjacent value of 7. And again, we'll find this value by dividing the top number by the bottom number. The instructions in the question ask us to round each one of these values to 4 decimal places. With our second triangle, our reference angle is still at the location of C, so our opposite will be across from that at 10. Our right angle points to the hypotenuse at 20, and the adjacent is the remaining side between the right angle and your reference angle at 23.36. So the sine of theta will be opposite, or 10, over the hypotenuse of 20. So again, in order to evaluate this, we'll do the top number divided by the bottom number. Our cosine of theta will be equal to the adjacent of 23.36 over the hypotenuse of 20. And we'll evaluate this by doing top number divided by the bottom number. Now we can find our tan of theta, which will be equal to the opposite, or 10, divided by the adjacent, or 23.36. And again, dividing top number by bottom number. And then we will round each one of our values to 4 decimal places as instructed. So far we've learned how to label the sides and then how to create the 3 different trig ratio setups. Now we can take this a step further and we can decide how we're going to know which ratio we will use based on the information that's given to us in the triangle. So we don't need all 3 ratios to solve the questions, we'll just need one of them, but we'll have to figure out which one will be best to use. We'll begin by labeling all of the sides of the triangle. So opposite of our reference angle of 45 is the value of x, that will be our opposite side. And across from a right angle, we have a 10, which will be the hypotenuse. We don't have an adjacent value in this case. Because we don't have an adjacent value, we won't be able to use either cosine or tangent because they both have adjacent values within their formulas. This will leave us with the sine ratio. If we look at our diagram, we can see that we have a value that we need to find, x, at our opposite side, and we have a number at our hypotenuse side. So this means that we can set up our ratio to be sine is equal to opposite over hypotenuse, which is going to be the same as x over 10. We'll plug in the 45 in the space of the theta, and this will leave us with our ratio. In a future lesson, we'll learn how to solve this ratio. In our second example, we'll place our theta or our reference angle at 45 again, and we'll look across from it for our opposite, but we'll see that there's no value there. This will eliminate the possibility of us using either the sine or the tangent ratios because both of them have opposite values within them. This means that we will need to use the cosine ratio. We'll continue labeling our triangle. Across from the right angle will be our hypotenuse. And that remaining side, which is between our right angle and our reference angle, is a length of 15. So now we know that for our adjacent value in our cosine ratio, we will put 15, and for our hypotenuse value, we'll put x. We've substituted our 45 in the place of our reference angle, or theta. In the last example, we have 50 as our reference angle. Across from that is x. Across from our right angle, we have an empty space. We don't have a value for our hypotenuse. This will eliminate both of the trig ratios that use the hypotenuse within their formulas. So sine and cosine won't be able to be used in this case. We'll have to be using the tangent ratio. Our opposite value is x, and our adjacent value is 5. When we set up our ratio, we will say tan of 50 is going to be equal to x over 5. So that's how we can set up the ratios. Like I said before, in our future lesson, we will look at how to solve the ratios.